So let's quickly do it. All right, so now this thing everybody can do. All right. Correct, right?
Yep.
And the reason for this is, quickly, 7, the times 4 times 10 plus 8, yes? And then by the distributive law, it's 3, 7 times 4 times 10 plus 537 times 8. And then now I can quote, this is 2148. 0, right? And this is 4296. And you look back here, and that's the same as if you have a 0 here, and then it's exactly the same sum. Good? Now, the reason I do it is, suppose I do it. Now, this is actually in response to a question raised in one of the comment cards last night. There's an alternate way of doing it. For beginners, this may be hopeful, but suppose I do it this way. I do it from the left to the right. So 4 times this. 4 times 3, 12, right? 4 times 7. I think I got it wrong. No, I have to shift it once. Sorry. You can see that I don't use this too often. Okay, so you have to, when you see this digit is 20, but instead of writing 20, you have to write it. All right? Yes, one level beyond. So instead of 20, is you write over there. Right? And 4 times is 12. Instead of 12, it's 12 here. And instead of 4 times 7, 28. Instead of 28 here, it's 1 over, so 28. Then, all right. 8 times this is exactly the same position, 56.
So you go back to the right?
From left to right. So this is the algorithm from left to right.
Wouldn't you do 8 times 5 first?
What?
8 times 5 instead of 8 times 5.
Oh yeah, sure. That's true. That's true. 40, right? 8 times 3, 24. Then 8 times 7 is 56. Now let's see if we get the right same answer. Right? So this is 6. This is 7. That is, wait. Oh yeah, 7. Yes? Yeah? So this is 5. We get the same answer. So do you think it's right or wrong? Is this the right way to do it or not? I get the same answer. Doesn't mean it's right, you know? Just because you get the right answer doesn't mean that you're doing the right thing. Aaron?
Can we know that this algorithm will always jump 2 spaces over when we start?
Well, that's part of the instruction, that if you multiply, you go from left to right, but when you use the digit which is second place from the, I don't know what we call it, the tens place, then you have to jump 2 spaces. And you do it here, then you know exactly what Yeah, okay. So, to make sure that, I didn't give you the full instruction. I just wanted to illustrate and open your eye to something that that you can discuss. See? So, for example, let's multiply. Yeah, that's a good practice for you too. Okay. I start from left to right, right? 6 times 2 should be 12. But if it's the third digit, or what do we got, the hundredth digit, then you don't just jump. Last time I was jumping 2, right? Last time jump once. Last time it was,
So you jumped to 10. So you really jumped twice.
yeah. So last time I jumped once. This time I jumped twice, right? So it should be 12 here.
No, you have to go.
No. Yeah. No.
Yeah.
This should be here, right? The instruction is if you're multiplying by the hundredth digit, you jump twice. So it's 12 here.
Yeah.
And 6 times 5 is 30. Should be here, right? Again, okay, 20. 6 times 7,
30.
it's,
Not 20, 30.
oh, 30. Sorry. Right? 6 times 7 is 30. Should be here, right? Oh, no. 6 times 7 is 42. Should be here, right? But the instruction is, whatever it is, jump twice. So make sure it's 42. And so on. Okay? And then now 1. Right? Should be 257 down here. But you have to, because it's the 10th digit, you jump once. Right? So it's 257. And then the rest is the same. 8, 20, and then, right? So let's do it for fun. It's 9. This is 17, and this 7. Do you have a calculator? Please check it right away.
Yes, it's correct.
It's correct.
157, 798.
You checked it. Right? Okay, so now it seems to give the right answer. Well, given the same answer twice, right answer twice doesn't mean anything. Is it correct or not?
It's correct.
Why is it correct?
Because 2 times 10 squared times 6 times 10 squared is 12 times 10 to the 4th. So you
Okay.
need 12 followed by 4 place marks.
Can you say a little bit earlier? What's at work? I mean, what is, okay, what can you describe it in one sentence? What are you doing? What does this say? What's underneath all this?
Place
That is important.
More than that, not just place value, but
multiplication.
okay, maybe I'm asking for the impossible. Yes. What you're doing. So, how did we get here in the first place? We're using distributive law twice, right? Once to go from single digit times single digit to multi-digit times single digit. We use it once, right? And then, once you know multi-digit times single digit, you go to multi-digit to multi-digit by using distributive law, right? But that's, remember each time, well, let's go through it one more time. Right? Just make sure you get it. When we went from 537 times 8, right? The way we could do this was because we wrote this as a sum by expanded form, then use distributive law on the left factor. Correct? But here, look at this. I'm keeping this fixed, but use expanded form on the second factor, distributive law again. So what we did, this is the so-called controlled application of distributive law. And here, I only keep this fixed and expand the second factor. So what's happening here? If not that I have told you everything, what's happening here? Distributive law by what?
Expanding
Both at the same time, right? 2557 is 2 times 10 cubed plus 5 times 10 squared.
Square. 2 times 10 squared.
Oh, 10 squared, sorry. Oh, 7. Instead of, now, as I said last time, we always held one fixed and expanded the other. But now I'm simultaneously writing both expanded forms at the same time, and then you have a free for all. Right? Or you squared. Sorry, this is squared. I left out the square. Now watch. Well, it suffices for me to do one for you, right? Why is this shifted 2 places over? Well, okay, what is this? Look at this and this. Multiply that. Yes, 2 times 6 for sure. What's the power of 10? You have 10, 10, 10, 10, 4 times 10 to the 4th. Right? So what happens? What happens is, yes, it's 12. It's a matter of where you place it. This tells you what? The 2 is not in the 10th place, but in the 10 to the 10. Anyway, 2. Okay, look. Yeah, it's 12. Sorry. Yeah. So that would be 12 times 10 to the 4. Right. So the 1 is actually 10 plus 2, right? So the 1 does not belong to the 10th place, but in the 10 to the 5th, right? 1, 2, 3, 4, 5. That's why it gets shifted over like that. And the 2 is in the 10 to the 4th place, right? 1, 2, 3, 4. And every single one of them is the same. Sorry?
Okay. It's the 1 is followed by 5 zeros.
Yes. Yes. Yeah. 1, 2, 3, 4. I'm counting the powers of 10. First power, second power, third power, fourth power, fifth power.
Why don't you start under the 7 to the 4th?
I could have. Say 4 to 5 zeros, same thing, right? Yeah. So up to you how you count. You understand? So this is perfectly correct. You want to do it this way, maybe make people feel better at the beginning. But you can't go on like this. Yeah, life is too short. So all these little things, if you think it helps your students to learn it, do it. But make sure they graduate to something better. Okay? All right, so let me see, wait a little bit, see if there are nagging doubts, residual questions.
So, if you were going to continue this, continue the distributive property, so it would be the 6 times 10 squared times 2 times 10 squared.
6. Well, we already did that,
Yeah, I'm sorry, yes.
right?
And now is it 5?
Well, you want to try another one? Sure. Why don't we try this and this? How's that? Right?
Would you,
So it's 5. Can you see this,
you'd also
Larry?
leave-
Larry? Can you see the blue?
If I zoom way in,
Do you see it? I don't think it's visible.
yeah, I see
You
it.
see it? All right.
but if you
5
follow the way-
times 1, of course. Right. Times 10 what? 10 what?
But if
Marlene?
you follow the way you wrote it
Square.
down, your next step would be 5 times 6 times 10 times to the first times.
No, we just test the case, simple test. I'm not doing it systematically. Is that what you're saying? No, I just want to show, take an arbitrary case. Right? So this is just 5 times 1. Right? So this is not in the ones digit. It's 10 squared, right? So should be here because this first power, second power. That's 5. What's the 5? What's the 5?
557. That's the
Oh yeah, 5. Okay, within 50. So that's what the 5 is. You do it systematically, you see. Yeah. By the way, you do it systematically. Okay. Last time, as I said what I said was right. No, I didn't say it. That's what the instruction comes with it. It says right. You multiply the top by this digit. The instruction is after you get the number, which as usual, which is whatever it is, 1, 2, whatever, right? You shift the whole thing 2 digits to the left. Let me repeat, right? The instruction of this particular method is that you multiply something in the hundredths digit. You shift the whole result 2 digits to a column to the left. Why is that? Well, because 6 is not. I mean, what's the 6? Yeah. The 6 is not 6. It's 6 times 10 squared. So every time you multiply something, the resulting power of 10 is shifted by 2, right? If this times this, it becomes 10 to the 4th. If this times this, becomes 10 to the 3rd. This time this 10 squared.
Right.
Therefore, the whole thing gets moved 2 places forward because that's what the power of 10 stands for. The power of 10 tells you exactly where you place that digit. Right?